Hello guys, how are you? This is one of the best engines in the world. This is the first engine ever to come up with a common rail injection, the electronic diesel injection from Alfa Romeo. It was Alfa Romeo department that developed this technology, and Fiat itself sold the patent to Bosch, for example, and other brands, okay? So this engine over here has over 250,000 miles, which is more than 400,000 kilometers. And there is only one way to kill this engine. And it is exactly what happened on this one. Even though it killed it, it is not dead yet. No, not at all. This blockhead and so many things on this engine are still good. In fact, I will keep a bunch of these parts because it is the same as it is on my sedan, okay, the 110 horsepower. So this engines first came up with 105 horsepower with a normal turbo with wastegate, then developed to 110 horsepower with the VGT turbo, very good delivery of power on that engine. Then the 115 right before the multi-jet engine, right before the 16 valve, and you still can find this engine on Alfa's 159, on Opel Vauxhall, for example, developing around 120 horsepower. But believe me, it seems a lot more than 120 because this little beast has a lot of torque down low, okay? It is really a good, an excellent engine, really good. So let's take it apart. See, this is already disassembled, all of it, okay? Let's just do an overview of this engine, what failed, why it failed, and how can you prevent it from failing, and some odds and ends of this engine. Before we get going, this engine was debuted on the Alfa 156 officially in 1997. This engine is still present on the Alfa's 159 right until the end of the Alfa's 159. And yes, this is the famous 8-valve engine that I'm always talking about. It is the best engine that you can have with reliability and performance, the balance of it. This is really the best engine that you can have. So starting here with the head, we have here the exhaust side over here. This goes to the intake manifold, as you can understand. And over here we have the passageway for the water manifold that passes around the exhaust manifold. So very similar to this twin spark engine manifold over here. We have the exhaust manifold over here, and right around it we have here the water manifold that goes into that hole over here, okay? This is for the twin spark engine. It's just for you to see how it's done. In here also you can see the date of manufacturing, you can see the firing order, and you can see the part number. This part number, like I told you on the head of the twin spark engine, no matter the age of the head or the application of it, being 147, 156, the Opel, Vauxhall, whatever, if you have this part number, if you are searching for this part number, no matter which the engine this came from, this is the head that you are looking for. For the timing side, we have here the water pump that goes into here. Beware that the water pump has the support for the sensor, the cam sensor over here. So in order to take out the water pump, you have to take out here the sprocket. For this camshaft, I will talk about that in a minute, okay? So we have here the water pump. This one was relatively new. The condition of the interior of the engine is very good, so the antifreeze was always a good quality one. In fact, I know it was always the original one. So down here we have this support. Depending on the car that you have, it may be different. Okay, so this is the part that goes to hold the sprockets and the bearing for the timing belt. It also secures here on this version the power steering pump, and down here the accessories belt tensioner. We will talk about this tensioner with more detail in a minute, okay? Down here we have the oil pump, and you have the sprocket for the crankshaft. About this sprocket, I already told you that you have to remove it to see if it has some damage when you have a failure of an engine. Here on this side of the engine, you have your intake over here. 1, 2, 3, 4. You have your holes for the glow plugs. Yes, I know they are very difficult to remove on this engine. Okay, sometimes you have to do what you have to do. And over here you have the holes for the injectors, the famous now common rail injectors that were developed specifically on this engine. So this engine, it is pioneer on this technology. It is really officially the first one to do it. Now over here on the back you have this support, and again it depends on the application that you may have on your engine, on your car. So this goes over here, okay? So you have your high pressure fuel pump for pressurizing the fuel to be delivered for the injectors. If you are curious about this technology, I already have a video. It is down below on the description so you to understand common rail systems. Down below here on the crankcase, you just have here 3 freeze plugs, okay? You have here some holes for securing here this bracket, this support, and you have here the hole for the oil switch. It is down here. So the alternator goes over here on this area, and you have here the oil switch that is behind the alternator. You also have here this breather pipe that goes to the crank ventilation, and you have down here the hole for the RPM sensor. I already have a video for this RPM sensor if you are curious. So on this side, nothing much to talk about. You have here the placement of the vacuum pump over here, okay? You have here your thermostat, again depends on the application that the car that you may have. And down here is where the gearbox goes and the flywheel. And again, if you have an Opel Vauxhall, you have a type of flywheel because you have another type of gearbox, for example. So it depends. You have the same block and the same head, but you may have a different flywheel, a different gearbox, a different thermostat, a different vacuum pump, okay? And finally, here on top of the head, we have the valves, the valve springs. Just notice the thickness of these valves. This is a good indication for what I'm about to tell you about the damage of this engine. These are 8 millimeter, my God, valves. They are very, very thick. So this engine still uses a bucket with a washer for adjustment of the clearance. And the factory says to adjust these buckets every 100,000 kilometers or every 60,000 miles. I can tell you that it is not necessary. This engine being 400,000 kilometers, 250,000 miles, never had a necessity of adjustment of this. In fact, none of these engines that I saw so far had the necessity of adjustment of these buckets. This is really the confirmation that it is very robust, very well done, this engine. It is really excellent. Plus we have up here, I don't have it with me, we have an oil injector, a oil squirter to all of the cam lobes in all of the bearings. So it is really an engine made to last. It is really a good engine. I cannot stress this enough. It is really an excellent, excellent engine, okay? So the bucket goes over there, as you can imagine. By the way, you can adjust them by just pushing down on the bucket with a tool and removing this, putting a different measurement of this big washer to do the adjustment if you need to, if you want to, okay? Right away there, you can see the indication of the damage that this engine had over there, okay? But let's talk about that in a moment. When I started the channel, I warned you about this tensioner over here. And as you can see, the tensioner is really, really bad. So we have a lot of play over there. It is really open. And over here is totally worn out. Which means that this tensioner does not work straight with the engine. It's not square. It is like so. Okay? Doing that, the accessories belt goes like this. It is the exact accessories belt for this engine that came out of it, and goes behind the cam belt, the timing belt going like so. Bits of the accessories belt pass underneath here this sprocket and the timing belt, making the engine not being synchronized anymore, and in that way collide on the inside of the engine. But the cam belt did not snap. In fact, what happens, it is the timing goes off of the engine, okay? It passes a few tooths, and in that way, the engine collides on the inside. Unfortunately, this happened on the highway at high speeds, and the damage was a little bit high. So what happened was, as intended, that temple over there broke, but it also broke here the bolt which means that the impact was a little bit higher than was intended, or this bolt was tight too much. So on the camshaft, you can see here the bolt on the inside, and you can see the indentation still living on the inside over there. Now, this camshaft, it may still be good. It may. I'm afraid that the part of the threading may be a little bit fragile, but I'll try to extract it anyway someday, okay? And possibly maybe it may be used on another application, because the camshaft is still really, with 400,000 kilometers, it is still really very good. The lobes are excellent. Like I told you, this engine is really very, very robust. Now you can imagine that with this collision on the inside of the engine, the valves may be bent. Let's find out. Again, do not forget that this low sprocket also may be broken like this one is, or may be fractured, may be cracked with hairline cracks, and you have to see that. For the removal of it, you already see me do it on the timing belt of the twin spark and on the chain of the Mito, and we have to have a tool for this. I do not have that tool right now because it was not mine, but with the timing tool, if it rotate or not, checking for TDC. Just another thing about this tensioner. Like I told you on that video, it is down on the description so you to understand. The reason why this tensioner fails faster is because of the pulley of the alternator. It has to freewheel to one side. This engine had that pulley failed as well. It was locked in place like a normal pulley will be. So that pulley damaged faster this tensioner over here, making it do this. So the reason why this engine is here right now is because the pulley of the alternator. That's it. One more thing that can accelerate even faster this behavior is a leak of the power steering pump onto this tensioner, okay? Because the power steering is right above this, okay? And it leaks oil, ATF, into this, and actually it will degrade faster here, this nylon strip over here, that with the alternator pulley, and we'll have a recipe for disaster. Let's take a look here to the block. It uses here a guide over here, another one over here. It is not on this engine because this engine was already disassembled when I got it, okay? Also on the twin spark, the eagle eye of you noticed that one was missing, yes, and I noticed that too, but I forgot to record it. I'm sorry about that. So you always have, not always, some engines only use one guide, but this multijet JTD and twin spark uses one over here, one over there, or crossed, okay? But always across. So the head gasket is a multi-layer one, and it always says top over here, always, if it is original, of course. It is a very sturdy head gasket. In fact, I never ever saw a JTD engine, never saw so far, a JTD engine or a multijet engine with a failure on the head gasket. Granted, on the newer models of the multijet engines, we have failures of the head itself, not the head gasket. For that, also I have a video down below if you want to find out why is that, okay? But here we go. It is a very common engine. It has these holes on the pistons, so you can have a swirl effect of the injection of the diesel, okay? That swirl, it will also not only swirl the fuel, but the air-fuel mixture, and in that way making a better bang. A better bang for your buck. Turning here the engine, you can see, I want to find out where the valves hit the pistons, and I can see over there one. In fact, I have a crack over there. Okay, it was really, really violent. About the crack, it may already been here before this hitting of the valve, because as the customer stated, this engine had a problem with the injector plugs, which were injecting too much fuel onto the engine, and as you can know, too much fuel onto the engine can crack a piston. So this one, but it coincides. So we have here a very evident mark
of the valve. I think here the piston. On this one, no heating mark and no crack, but we have a heating mark over there on this side, but it's very slight. Okay, so this was also the reason why the customer did not want to repair this engine, because too much stuff was accumulating. So new pistons, boring of the block, and so much stuff. So he opted for a good used engine with only 200,000 kilometers. And yes, these engines can last you about 800,000 kilometers to 1,000,000 kilometers, no problem, if this kinds of stuff do not happen. The fourth piston is just like this one, the third one, and the first one over here, it is just like this second one. So with this tool, I am locking the engine on TDC, and in that way I can check above here if the piston is indeed on TDC, and in fact it is, which means that this cog did not break, but it may be fragilized. So on these occasions, I always recommend you to replace it, because it can crack afterwards, okay? But this also tells me that the impact was not all that bad. That bolt that broke on the top pulley, possibly it was over tight, and that was the cause of the breaking. Why I'm telling you this is, most of the times when this happens, you can take out everything and put a new belt and the engine will run perfectly. It is that robust, okay? This engine is really that robust. If this bolt does not break, you will not cause so much damage on the engine, and if only this little part there breaks, you can replace this one and put the new belt, and the engine will run perfectly. In fact, this happened on my sedan 14 years ago. The car was one tooth out of timing. It was, and the valves were hitting the pistons for about 15 days, and I finally found out what the problem was, put the engine on timing, and I just hope and pray that everything was okay, and in fact 14 years later, it is still perfect. And so this really begs the question, how is the rest of the engine? About the bearings, the rod bearings and the support bearings. How are they after 400,000 kilometers? I really do not know. I just cleaned out the exterior of the block. I did not want to mess with it because I do not want to lose the film of oil, okay? Because I want to save this engine. But I'm really curious to know how are the support bearings and the rod bearings. Preventively, I already took out some of these oil sumps to see the bearings, and I already see them with 800,000 kilometers, and the bearings were like new. Oh my god, these engines are really very good. But let's see how it is on this one. That being said, this does not mean that we have to disregard the oil changes and the antifreeze replacement. Talking about antifreeze or coolant, that is a second way to kill this engine, or any engine for that matter. Unlike my turbo diesel or my 75, for example, the Balbero, there is not a drain for the coolant. That is very unfortunate, because we will have a lot of debris building up here on the coolant passageways. So as you can see, the condition of the engine, apart from that over there, is very good on quality of the passageways of the waterways. If you do not have enough care for the coolant, this will start to build up mud and crud and start to fill up these holes of the coolant system. In that way, having a poor cooling of the engine. One way that I'm seeing here to remedy that is this freeze plug over here is the lowest one. Yeah, it is the lowest one, and the excess is not all that bad. In fact, it is the easiest one. You can do it is maybe every 100,000 kilometers, for example, remove this freeze plug, remove all of the coolant in this way, and put a new one. Yeah, that may be the way. I have to experiment that with my 156. Both of them, actually. The idea now is not to remove everything, it's just to take out here the caps, 1 or 2 or 3 or whatever, to see the condition of the bearings. That is the intention of this next part. I do not really want to take out everything. The pistons, it's not really relevant to remove them because I know the pistons are not good, so it is irrelevant if they have a lot of wear or not. So to reuse this engine, I will bore out to the next oversize. I do not want to mess with anything STD on this engine. Being 400,000 kilometers, probably has to have a oversized piston. On the last support bearing, yeah, with 400,000 kilometers, it is not as good as I was expecting, but is at the same time not bad at all. Not bad at all. By the way, the support bearings are numbered, so this is 0, 1, 2, 3, 4, okay? And these ones do not appear to have any mark to say that they are like this or like this, but let me see if they go in. No, they do not go in, okay? So there is only one way to put them in place. Okay, so number 3, so 5 support bearings overhaul. We have here a bit, okay, just a little bit of wear over there. Again, 400,000 kilometers. But we have no scratches, which is very, very nice. Just the normal wear. I believe with a normal overhaul on the engine, on the inside, if I need to, again, if I need to, when I need to, it will be enough. On this center one, the third one is the most affected one. Okay, but again, just wear, normal wear, not scratched. The second one, it is better, okay, not bad at all. The crank itself is very, very good, very shiny. No scratch marks. This is the first one. And as you can see, is similar to the other ones. Some of you asked me if you are able to replace the half bearing on the other side without removing the crankshaft. Yes, you can. So the engine being on the car, on this moment you have the weight of the crankshaft all going down. So you will be able to do a simple rotation of the bearing, so you do not have at this point the weight like it is right now. The weight of the crankshaft will be out of the bearing, so you can easily rotate the bearing out of its place, and in this way, or spin the engine or something, okay, you can take out the F bearing to the this side, and as you can see, so these bearings are to be replaced anyway. So as you can see, you can take out the old one and you can introduce the new one in the exact same way. Already did it on some engines and it is in fact a good way to do it. Okay, if you are STD, of course. If you are not, you have to measure everything. So the rod caps are next. This is number 3. So 1, 2, 3, 4. Let's see how are they. So okay, normal wear for 400,000. The crankshaft is perfect. Let's see here the upper half bearing. It is also in good condition. Okay, it's reasonable. Obviously, if I am to use this engine, everything will be new, okay? But possibly STD, everything, possibly. To put in the cap, you have a mark over here of the number. So it will say number 3 eventually. Right there, okay. And also this one has number 3. But if you do not know, this indentation over there has to match with that indentation over there. Okay, like so. Now number 2, same story. Exactly the same as the number 3. On the other side, just the way that number 3 is, with just a bit of wear, nothing too major. And again, the crankshaft is perfect. Even though the engine collided, as you can understand now, the wear of it is very good. Now here number 1, again the same story, completely normal and the same as the other ones. The crankshaft is perfect, mirror finish, and the other F bearing is also in very good condition. Very good. I think it's the better one so far. Okay, up you go. And number 4, the same thing all around. Crankshaft brilliant, other F bearing exactly the same as the other 3. So to do a quick test here on the valves, what I like to do is to find a very clean surface and very straight surface that you can trust. Normally a stone table is the best, but obviously they have to be seen on the machine shop. But if they do not wobble, for now they are good. You can also put it on the drill and see they do not wobble. Okay, and repeat the test on all of them. The worst ones were the 3rd and 4th. So let's see. Just a little bit of wobble. Do not know if that is from my drill, because the grab here may not be perfect. These have to be seen on the specialist, but they are not bent like crazy. Okay, so this goes to show this one, it is a little bit bent. This just goes to show the toughness of this engine. Oh my god, really very good. This one is better. So this one is really not that great, because you do not need to buy all 4+4 valves. You can buy, very good, this one. You can buy them as a unit, one by one. Very good. And this one had a X, meaning that it was the one that really collided with the piston. Very nice. So like so. Okay. Okay, I can feel the vibrations or not on the drill. This one is the one that had the most of the imbalance, apparently. And apparently this one did not hit all that much. Perfect too. So only one valve is a little bit, just a little bit, let's try again. Yeah, just a little bit out of whack. So in order to rebuild this engine, possibly only one of the valves is not 100%, but like 98%. So this one is bad, okay? So here on the head you can see the placement of the glow plug. This is for the injector. So being direct injection, it goes directly to the combustion chamber, the tip of the injector. Right here again, the glow plug, injector. Another reason why these valves will last you so much is because, yeah, a little bit of play over here. It is because they are straight onto the engine. They are not like this. They do not work at an angle. They work like so. What may happen sometimes is they impact the piston. They may be a little bit deformed here on the body, and in that way do not do this work all that great. Okay, so even if they seem not to be crooked, you always have to test everything. So the guides are just a bit worn out. Remember, 400,000 kilometers. Yeah, there's nothing on this one, no play whatsoever. 400,000 kilometers is a lot. Just a little bit of play, nothing too much. This one, nothing. Okay, I'm seeing a pattern over here. Just a bit of play. And nothing. Okay, so 4 guides, 1 or 2 valves, a resurfacing, cleaning, and that's it. Back here to the block, we have here the part number for the engine. If you are searching for a block Again, just like the head, if you have this number over here, it means it is the block that you are looking for. And yes, you have here a number. I don't know if you are able to see it, like so. It means it is a AR mounted on an Alfa Romeo 37101. So this is a type of engine, but that does not mean that this number does not work, because if it is mounted on a GM platform, this will not be the same, but the part number will be the same. So this means that this part number is applied on this number over here. So it is applied on the Alfa 156 with this engine number. Right below you have a serial number, and that is in fact the number of the engine, not the part number, the serial number. The part number is that one, 46414948. Also here on the engine, on the front of the engine, we have here this hole that goes to the turbo. This hole provides oil pressure to lubricate the turbo, and this hole over here is for the spent oil to go back to the inside of the engine, okay? On this side here we have the oil filter, but before that the oil filter heat exchanger, or that thing that goes to the radiator, okay? So here on the engine, that is it. I hope you are liking these videos of teardown of engines. This one was not to be right now, it was to be that 33 over there, that boxer engine. But I had this one here on the corner, and it was getting in the way. So I just decided to do this and to finalize in the big time over there with that boxer one. That one will be a bigger video. As you can understand right now, the 33 videos are getting big and bigger, and that is really how I'm intended to do them, because I want to be very thorough, very particular about a lot of stuff on that car. Engine, gearbox, suspension, everything will be very thorough, as much as I can, obviously, okay? Don't forget, guys, that this new era of the channel is very complicated to do 100% of the time. If you are able to do a support of the channel, down on the description there are links for that. If you are able to, I really hope you can do that. It will be very, very good for the channel to be able to give you more and better, and to be able to do this and other projects that are still in the waiting list. Also, down on the description there are a lot of videos and playlists that will be useful for you. I'm talking about brakes videos, for example, problems and solutions with brakes, lack of power, crank no start, electrical issues, mechanical issues, clutches, so many things that are down on the description. So many videos that you can see what they can do for you. I see you next time, guys. Bye.